All right, so we're going to finish up this week still solving equations. Okay, the only thing that's going to be a little bit extra today is you're going to have variables on both sides. Okay, so when you start putting variables on both sides, what it does is it gives you more options when you're solving it. Okay, you have to decide, you get a few more choices. Okay? And a few different things can happen that haven't happened before. All right, so until now, all the equations we've solved only had the variable on one side. Okay, we're going to go over the steps again for solving equations.
And again, they're pretty, we're going to talk about that in a second, but the steps are pretty much the same with a little change to the A part. Does anybody remember from yesterday and the day before, the first step? Anybody remember what that is? Sandy? Simplify, right? That's the big part, simplify. Under simplify, right, there's two things that could happen, right? One of them we didn't do yesterday, the other we did. What's one of them that could fall under the simplify step? Anybody remember? What's one thing that could fall under the simplify step? Joe?
On the paper, does it have it under?
Okay, that's all right. You don't have to worry about it. If you can't write it, that's okay. Yeah? Yeah, we could combine like terms under simplify. That's one thing we could do. All right? And what's another thing? What's another thing? All right, we talked about combined like terms. What was the other thing we didn't get to yesterday? But we talked about it a little bit. We didn't have any examples that had this part of simplify, but it could happen. Distributive property, right? So combine like terms and distribute. All right? If you guys, if you can, under the simplify part, I know there's no like line there for it, but above the M, if you could squeeze in combine like terms, if you could write this, then you get a little bit of space to squeeze it in there. I'm not sure why it didn't show up. But don't worry about distribute. We're not going to get to that today anyways. We're not going to have any problems that have that. But right in the combined like terms part. We're still going to have that step.
Okay. What's the A stand for? What's the next thing? After you've done the distributive property, then you combine like terms. Sophia?
Addition.
Addition or subtraction. Yep.
Oh, good. Yeah, it's backwards.
What's that? M?
So just guys, do me a favor.
M is the last thing.
Well, it's
No,
not.
I got screwed up. Change the M to an A, that's all. Change that M to an A. These might have been the old notes. Sorry guys. And then write on that big line, write an addition and subtraction. Just change that M to an A.
Hey, and under addition and subtraction, basically the goal, if you can, is to try to keep the numbers positive. Okay, if we can, we try to avoid negative numbers just because negative numbers are harder to deal with, and that's what this is saying right here. Right, so if you can, when you're doing addition and subtraction, if I had something like 3x plus 2 equals 8x minus, or let's say plus 10, what I would do is move the 2 to the other side. I wouldn't move the 10, because if I did, then I'd end up with a negative number. Okay? I would bring the 2 to the other side. Okay, so that's all that step is saying. If you can, try to keep your numbers positive. Okay, and this one, you have a spot, you can copy that one
Yeah,
down
give
too.
that spot for that. It's been the one from 2 years ago on this team. I'm not sure what happened there. Sorry about that. We'll make it work.
Great, and then after you do your addition and subtraction step, does anybody remember what the last step is? Multiplication and division. So now you do your multiplying and dividing. So you're basically still following the same steps. Simplify, then you're adding and subtracting, and now you have a choice. Okay, and we try to make the choice that'll leave numbers positive. That's not always going to be possible. Sometimes you're going to have to deal with negative numbers, and that's just the way it is. But if we can, we'll try to avoid them. And then the last step is multiply or divide. Yep, same steps as yesterday, same order. All right, so let's go through those steps with our first example. Okay, 7y plus 13 equals 5y minus 3. Okay, so first thing I'm going to do is look at my simplify. Do I have any distributive property that I need to do? No, no distributive property. How do I know that? There's no parentheses. Okay, how about combine like terms? So remember, combine like terms are on the same side. Any like terms on the same side? No. So now we can get into adding and subtracting, and we're going to start moving stuff from side to side. All right, so let's start with the number. Okay, we have the 13, we have the negative 3. What's one thing I could do, and if I did it this way, I could keep all my numbers positive. Joe?
Add negative 3. Add 3 to both sides.
Right, you could add 3 to both sides. Now, what's another way you could do it, but if you did it this way, you're going to end up with a negative for now. Yep, Joe?
Subtract 13 from both sides.
You could. Okay, you could subtract 13 for both sides, but we're not going to do it that way, because if you do, you're going to get a negative on the right side. So I'm going to do it the way Joe said first. Add 3 on both sides. And Xander, can you tell me what I would have on the left-hand side now? The whole thing? All right, so 7y plus 16 equals 5y. Okay, so we got that. Now, we've got all the things that don't have a variable on the left. Okay, the 16. That means everything that does have a variable needs to go on it's got to go on the right. Okay? So, how would I move this to the other side? Yep, Paige.
You would minus 7y from both sides.
Minus 7y. Minus 7y. We're going to get a negative, but there's not really anything we can do about that. Okay, it's just the way it is. And Paige, can you tell me what my new equation is now?
16 equals negative 2.
Yep, negative 2
Y.
y. Okay, now we've done all the addition and subtraction we can do. We're down to our last step. Is there any multiplication or division that would help me finish that up? Jenny? Divide both sides by, can you say it again?
2.
Well, if you divide by 2, you would be left with a negative y on the right side. So how do we get rid of that negative and the 2? What would we have to divide by?
16.
Not 16. I like the 2 because that cancels the number in front of y, but you want to cancel the negative with it.
Gene, you're just missing something. You're missing something with the 2, that's all. It's not the y. You want to divide by 2y. There you go.
-2. So now, if you divide a negative by a negative, you get a positive. So last step, can somebody just tell me what's 16 divided by -2? Yep. -8. Okay. Any question on that? No? Okay, so that's basically what we're doing today. Just got variables on both sides. Okay. Example 2. What's going on here that didn't happen in example 1? Something extra. Something extra. Connor, do you know what's happening here that you got to do that you didn't have to do in the first one? Okay, it has something to do with
So
that.
you have 3 variables?
Well, 3 terms with the same variable, right? Yeah. So what do you have to do on the left-hand side?
Connor, where, you see the equal sign up there? Where are 2 of those variables? On the left side. Okay, when they're on the same side of the equal sign, what can you do with them? What do we call that? It's like it's one of the things under simplify. I think simplify step, right? No, under simplify, right? What can we do? We can distribute, which we don't have parentheses, so we can't distribute. What's the other thing we can do? Under simplify. We can distribute, or we can. If you're not sure, that's okay. Okay. Paige, what is it?
Add like terms.
Combine like terms. Right now, back to you, Connor. On that left-hand side of the equal sign, what are the like terms? And make sure you tell me if they're positive or negative as well.
8h, -3h.
Nice. No, and stop. That equal sign is like a wall. We can't go beyond that. We can only stay on. When we're combining like terms, we can only stay on that side. We can only partner them up and make them bigger or smaller if they're on the same side. There's a wall there, it's blocked. That's a whole different thing on our opposite side, right? Then you're going to give them like a ticket to go to the other side, opposite side, all that stuff.
All right, so now we know what we got to do. We got to combine like terms. Connor told us what the like terms are. Can somebody tell me what you get when you combine the like terms? Madison?
You get 5H
5H, and anything else that's still there?
plus 5.
Plus 5. Now you're down to a problem just like we had in example 1. We've got a term with a variable and without on the left, with a variable and without a variable on the right. It's pretty much exactly the same thing. Okay, that was the extra step. All right, so Gemini, what do you want to do from here?
Add negative, like add 4 on.
Okay, yep, that's fine. You can add 4. You can add 4. And can you tell me what I have for a new equation now?
5H plus 9 equals 8H.
Yep, I like it. That's good.
Now, guys, in that step that Mr. Hager just did, right, when he added 4, what else could he have done and not have been wrong? If we're following, I mean, even if he didn't follow the steps, what's another option he could have had there to do? Anybody think they might know? Something else that he could have done instead of adding 4? Joe?
He could have subtracted 5.
Could have subtracted 5. He wouldn't have been wrong. But why do you think we're telling you guys to move the smaller number, or the number that's worth a lesser amount? Do you know, Gemini?
I'm trying to get rid of the negatives.
Yeah, we don't want to deal with negatives. That's why we're telling you to move the smaller one, right? Because then we're going to get literally dealing with positive numbers. But he could have minus 5, he could have minus 5 from negative 4. You would still get the same answer, but again, you're working with negative numbers. We think it's a little bit easier to work with positives. I mean, he could have, if he wanted to, he could have minus 5H, minus 5H. He could have minus 8H, minus 8H. He could have done that too. I think it's easier, I think we think it's easier to move the numbers first, but if you didn't move the variables, you're not wrong.
All right, so Mackenzie, now I have everything without a letter on the left. So that means everything that has letters needs to go on the right. Yep. So this needs to go on the other side.
And guys, when I get to this point, I kind of look at it and say, okay, I got 3 things there. At this point, one of those things is not like the 2 others. I gotta move, right? Whatever that one thing is, I want to get it by itself, and I want to get the other things by themselves.
So we're still under that addition and subtraction step. We haven't finished doing all the adding and subtracting. So how about Nathan? Can you tell me how I would move that 5h to the other side? Remember, we're still under the adding and subtracting step. So it's going to be one of those 2 things, either adding or subtracting. Which one do you think we have to do here? Okay. What would you subtract to get rid of that 5h and make it 0? Just subtract 5h. Perfect, yeah. Subtract 5h. And make sure we do it over there. So Xander, can you tell me what I have now?
You have 3H.
Where do you want me to put that?
On the right.
On the right? Good.
And the positive sign
Yep. And that's
on the left.
on the left. Yep. Okay, so now we're down to the kind of problem we did on Tuesday. Now we're in the multiply divide step. Would I have to multiply or divide to finish this up? Yeah, a mass.
You'd have to divide 3 by both sides.
Yep, I'm going to divide both sides by 3. By 3.
Madison, why not divide by 9?
Because you're trying to get the variable.
Good.
And what is that going to give me for answer? Yeah, Joe?
3.
3. Okay, so h equals 3. Okay, any questions on that one? Now, what else can happen when you're solving equations? Like right now, when we solve this, we got one answer, right? 3. We solve this,
And a nice 1 answer.
one answer. Does anybody know something else that can happen from studying solving equations in the past?
Another possibility.
There's something else that can happen, and we haven't done it yet in this class, but we're going to as I think the next problem. Yep.
You have 2 answers.
All right, some problems can have 2 answers. Our examples will never have exactly 2 answers. But there are some problems that could have 2 answers. But this one won't have exactly 2. Anybody know what else can happen when you try to solve an equation? I think I have one. We'll just try it. Let's try this one, and then maybe Mr. Roy can do the next one.
Sure.
Okay. 4 plus 5x equals 5x minus 3. All right, so let's start it just like we normally would. Anybody tell me what I should do for my first step? Sophia?
Would you add 3, so then I do 3 on the right side, and then add it to the 4?
Yeah. So I'm going to add 3 on both sides. What's 4 plus 3 give me?
7.
7 plus 5x equals 5x. So now we put the 7 on the left. We put things without variables on the left. That means in this problem, things with variables are going on the right. So don't tell me what's going to happen yet. Just tell me my next step, and then we'll go from there. Gemini?
You're going to divide the 5x on the
Not yet.
That would be the next step.
We're still in the,
You're gonna add 5 on both sides? Add 5 on both sides? Subtract 5 on both sides?
which one? Would you add or subtract?
Subtract.
You'd subtract, because you have a positive 5x, you have to do the opposite, minus 5x. And make sure when you do it, line up the column with the variables. Don't put the minus 5x under the 7. Okay, you can't do that. Put it with the x's. And now I get 7 equals, what's 5x minus 5x? 0.
No, because it's 0, so don't.
It's just 0, yeah. If you have 5x and you take away what you have nothing left. Now what? Yeah.
Wouldn't this be considered undefined? Or no?
I see what you're kind of getting at. We just
Kinda
use
like
a different word to describe it.
Okay.
Does anybody know what the answer is to this?
Guys, remember when we had to check them, right? You say solve and check. What happens on both sides of the equal sign? We get x equals 3, whatever. We take it, we plug it in, right? Wherever x was in that equation, and then we check it. What should happen on both sides of the equal sign? Yeah, like Joe and I just said, it should be the exact same number, right? That's why we know it's a solution. What about this? Do the numbers match up? So what does that mean? Is it a solution? So what's the answer? Say it, Mallory.
Sorry, no solution?
No solution, right. If it's, guys, that's not true. 7 doesn't equal 0, 0 doesn't equal 7. If it's not true, if the numbers don't match up, it's no solution.
Yeah, so when all your variables disappear, you're solving a problem, you've done everything correct, and all your variables are all of a sudden gone, it means one of two things just happened. This is one thing, no solution. Meaning, no matter what number you ever pick for x, you can never make this true. It's impossible to solve this. There is no number that would ever
Plug in for x.
make it work. Anybody know what the opposite of this would be? Yeah?
Infinite solutions?
Yeah, anything is a solution. Okay? And I'm going to hold off on that. Mr. Roy's, I think, going to go through one like that. Okay, but I'm just going to write down what we just said. Okay, so it's possible that when you solve equations, you don't always get one nice answer like the first two. It's possible you get a no solution, like we just did, or what Xander just said, any number is a solution. Okay, or the amount of solutions is infinite.
Hey, you can plug in any number you want for the variable, and you'll get, whatever you get for an answer will match up on both sides.
So does anybody know the name of that? It's probably a tough word to remember.
Didn't Xander say it?
You said infinite solutions? Do you remember the name of the equation?
Oh, okay.
What that's called? The type of equation that has infinite solution is called an identity. Okay, so an identity is an equation that there's infinite solutions for. This kind of equation, we call this a contradiction. Because what's on the left and what's on the right, it's like they contradict
They don't
each
match
other.
up.
Yep, you can never solve this. Okay, so those are the two cases to look out for, okay, besides just the normal ones we've had all week.
Mr. Hager, on the test tomorrow, if they put infinite, would you accept that as an answer? Do they have to put identity?
I guess it depends on how it's worded.
How many questions are on that test?
16.
16. Some are multiple choice. Like about half, maybe even more than half are multiple choice.
So if it's said to solve, when it asks you to solve, what that means is how many solutions are there and tell me what they are. So if you had an equation like this, you've solved it. You've told me h is 3. This equation, if it said solve, you write no solution. You can't solve it. We'll look at another one in a minute where if it says solve, you put infinite solutions. Okay, so if it says solve, then you put infinite solutions. Okay. All right, so Mr. Roy is going to take you through.
Thinking, guys, we're just solving this one. We're not checking it. All right. right, so this is what, example 4, guys? All right, cool. Fred, what's the, if we're following our steps? Yeah, I know, I called it wrong, I'm sorry. What's the first thing we have to do? Just tell me the first step. Simplify, right? All right, so Fred said we're gonna simplify. Ginny, what's one thing or one step under simplify? 'Cause there was 2 things under simplify that you could do. One is there and one is not there. Okay, we skip, remember under simplify there were 2 things that you could do. So it was like simplify and, do we have like terms? Is there distributive property there? Mallory behind you shaking her head, no. Mallory, why do you say no? Yeah, it's gonna be parentheses. But I agree with Ginny, there are like terms. Can you tell me what they are? Tell me if they're positive or negative as well. Is that, so just remember, what's the catch with like terms? Where do they have to be?
On the same side.
Right, they're gonna be on the same side of the equal sign. You can't have 2 on one side and then 1 on the other. These are, I agree with you, this, and this are all like terms. The only 2 you can combine are these 2, because this guy's over here, we can't touch him, he's blocked by that wall, by the equal sign. All right, Ginny, do you know what we would get when you combine those 2 things?
7.
Careful. Which number is bigger, 5 or 2?
5.
So when we're combining numbers, right? And they have different signs. This is a positive and this is a negative. Which sign do we take? The bigger number or the smaller number? The biggest. Which one's bigger? 5. And it has what kind of a sign? So my answer should have what kind of a sign? Negative. What's 5 minus 2? 3. Did I miss anything? A. Good. Gone. Connor, I'm not going to ask you to answer anything. Can you just tell me what else I have to write after the negative 3a?
Plus 4 equals 4, negative 3a.
Equals 4. What was the rest of it? I didn't hear the rest of it.
Negative 3a.
Minus 3a, negative 3a. I know what you mean. Very cool. Thank you, buddy. Appreciate it. Okay. Noah. So we did simplify, we combined like terms, there was no distributive property because like Mallory told us, there were no parentheses. So what point are we at now? Add or subtract, right? Are we gonna add or subtract the variables based on our steps? Are we gonna add or subtract the variables or the numbers? Numbers, okay. Which one do you wanna move? The 4, which one? This one or this one? One on the left? What operation do you want to use? Minus 4, else am I going to minus 4? What else do I minus 4? For another side, cool. Thank you. This negative 3a just comes down. We've done that. What happens here, Noah? Cancels out. How about on the other side? Cancels out. Just so happens on this one that they both cancel out, right? And now we get a negative 3a equals a negative 3a. All right? What can we do now? Divide by what? Negative 3. When I divide here, right? What's going to happen? Cancels out, and I'm going to be left with what? Cancels out, all I'm left with is the variable, right? A. On the other side? A. Do they match up? And say, am I okay there?
Usually we get a number equals a number.
Okay. Oh, why we didn't?
I probably did something.
We didn't. I was thinking that too, Ms. Jager, why that happened. I don't know why. And this is one of your examples too, just for the record.
Yeah, what?
Yeah, wouldn't that be 1 because 1 going, 3 going, 1.
Well, I guess we can move that, I guess, right? we could add 3A, right?
Yeah, if you want to get all the A's on the same.
All right, so let's go back. We'll fix this. I got ahead of myself there. So we're gonna have negative 3A equals negative 3A. All right? Oops. What do we want to do now? What am I gonna do here? Add 3A. I went ahead, I'm sorry, guys. Add 3A, right? What's gonna happen here? Cancels out to be what? Oh, whole thing's gone. Same thing happens over here, right? Cancels out. Do they match up? 0 equals 0, right? So what does that mean? How many, what's the solution? Infinite, right? I got ahead of myself there, guys, I'm sorry. All right, it's infinite because they both match up, right? 0 equals 0. I could plug in, sorry, go back. I could plug in any number I want for A. I could plug in 1. I could plug in negative 105. I could plug in negative 1,332, whatever. If I plug that in, when I check it, it'll be a different number, but on both sides, it'll be the same thing. It'll match up. I can put in any number I want, right? Any number I want will work. So when it matches up, it's infinite. And they have the same, the variable will be gone. Somewhere along the way, the variable will cancel out. And then when the numbers match up on both sides, then you'll have infinite solutions. All right, so same thing here. Something similar here. But this one's a little bit different. Not much different. There's just a little more work here than we've done in the last couple. All right? So I'm going to, right off the bat, I'm going to tell you that there's no distributive property because there's no parentheses. Okay. Anybody see what we can do first? Mallory?
3x minus 2.
Positive 3x and a negative 2x. When I do that, Mallory, what do I get?
You get just x.
X. If you put 1x, you're not wrong. Minus 1x. If you put minus x, you're fine too. All right? So we'll get 5 plus x. Right? Here's the catch. Don't mess up your sign. 3 is positive. 2 is negative. 3 is bigger than 2. That's where I got the plus sign from. I want to take the sign of a larger number. Okay. Cool. How about on the right-hand side? X?
Plus 3x, plus 2.
What do you mean plus 3?
Bring stuff down.
You could. You don't have to, but you could. You want me to bring stuff down? I'm asking you, big guy.
Sure.
You tell me. It's your world. I'm just living in it. That's what I tell my wife. It's your world. I'm just living in it. All right. Cool. So I brought everything down like Xander asked. Anything else?
Oh, you can combine with.
Nice job. All right. What are the like terms, Xander? Tell me if they're positive or negative.
4x is negative 3x.
Positive 4x, negative 3x. When you combine them, what do you get?
No.
1, right? Just 1, or x. All right? So I'm going to get 5 plus x equals, when I do this, I combine them, I'm going to get x. Remember, it's a positive x. 4 is bigger than 3, 4 is positive, my answer has to be positive. What else do I have to do on this side? Anything else? Bring the plus 5 down. All right, so I've done my, this one was different. How is this one different than the last couple that we've done? Joe?
No, you don't have to combine like terms.
Yeah, we had to combine like terms on both sides. The ones we've done before, there were a couple of them were no combined like terms. We had to combine, there were none there to do. This one, what we did before was only like terms on one side. This one has it on both sides. That's what makes it a little bit different. All right? What can I do now, Paige?
Add minus 5 to both sides.
You want to minus this 5 or one on the left and one on the right?
Left.
Left, okay. So minus 5 to the one on the left to where?
The one on the right.
The one on the right. I agree. What's going to happen?
They're both going to cancel.
Cancel. cancel. All right? X equals X. Remember, we want to get the variables on one side. Joe,
You subtract X from.
subtract X, right? Minus X, minus X. What happens here? What do I get? Nothing. A red nothing.
Zero.
Don't tell me why. Over here?
0 equals X.
But you can't see it.
Huh?
I'm thinking to myself.
This cancels, that cancels, they come out to 0. They match up, right? Connor, what does that mean when they match up? How many solutions? Starts with an I. Infinite, right? Like Buzz Lightyear says, to infinity and beyond. Infinite. I'm telling you right now, guys, tomorrow, no solution in infinite may show up on the test. All right? And guys, once we give you guys a little bit of time at the end to print off your reference sheet, I'll tell you exactly how many multiple choice there are and how many short answers there are. All short answer is, it means the answer, you can't pick an answer, you actually have to do all the work and show us. All right? Joseph. Hold on, guys.
No solution, instead of saying that, can we say undefined?
No, we want you to use the term no solution, please. Okay? I know, don't get mad about undefined, I'm sorry. Ms. Hagen, you want to take this one? Want me to do it? Okay. Go ahead, you can do it.
All right, so this
Oh,
one
that could've-
is about a pizza shop, and they sell two different kinds of pizza. Okay, what's the first kind of pizza? Yeah, and maybe they sell more pizza, but these are the only two we're looking at. So cheese pizza,
Guys, it's on the back. It's on the back of your notes if you don't see it.
and it says the cheese pizza is $10 plus $1.50 for each topping. So if you got a cheese pizza and you got one topping, how much extra would you pay for just one topping? $1.50. What if you got two toppings?
$3.
$3, because you pay $1.50 each time. So how could you write a formula for that?
It has to have a variable.
10x plus 150.
No. Cost equals cheese, $10.
You pay the $10 plus, how would you write something with a variable? Because the number of toppings, you could get two, you could get 150x. Yep.
Again, you don't know how many, you can plug in any number there and get the cost. If you had 5 toppings, you can plug in 5 to the X and get the cost of your pizza.
Now, what's the other pizza that we're looking at?
$4.50 for cheese pizza and $1
What's the difference?
Well, we're going to change the name. It's not going to be cheese. What do you want it to be?
Pepperoni pizza.
Hamburger.
Hamburger?
Hamburger.
Meat?
What would you like to read?
All right. Meat lovers pizza.
Yeah, just don't like his meats.
So it's $12.50 for the meat pizza and $1 for each additional topping.
Like, only got it wrong.
So anyone think they could give me an equation for the cost of the meat pizza? Cost of the meat pizza. Now?
$12.50 plus
$12.50 plus $1 per topping, so plus 1x, or you could have just put
How many
x.
meats
If
are
you
on
put
the
1.00, that's fine too.
Now, it says to write and solve an equation where you would pay the same amount. So they want to know where the cost of a what pizza
cheese pizza?
is the same as the cost of a meat pizza. So this is the question. Where does the cheese pizza cost equal the same as a meat pizza cost? So let's start with the cheese cost. What's our formula for the cheese
How are we
cost?
expressing cheese cost? What formula are we using? Or expression?
All the stuff we just
It's
did.
already written up there, guys. You don't have to pull it out of the air. You already
10
did
plus
it.
150, yeah.
Yeah.
Yep.
Minus X on both sides.
And how are we representing the cost of a meat pizza? 12.50 plus 1x. Now you're going to solve it just like we did the other problems. This one's a little easier because you don't have to combine like terms. So what would be the first thing I would do? Xander? So you can. We usually move the number first. The number without the letter. Yeah?
To subtract 10 from both sides?
Yeah, I would subtract 10 because if you do it that way, it's going to keep the numbers positive. So what does that leave me with on the left?
Well, that's gonna be 250.
On the left?
Yeah, 250.
150.
Oh, wait.
She said she was doing the math on the right-hand side, Mr. Hager.
And then what do you get on the right? Go ahead. 250.
Two more steps.
What are you going to move to the other side? So we put things without variables on the right, so now you want to put all the variables on the left. So how would you move that x to the other side? Well, if you want to put, you said variables on the left, right? So subtract
Oh, you subtract 1x.
1x and 1x. Okay, what does that leave me with on the left?
50x.
Point, yeah, 0.50x.
Last step.
Usually toppings are like 50 cents. Rip off.
You're talking about going to $1.50 each time. Literally, yeah.
So Noah, what's my last step?
I can't really. Eyes are killing me.
Noah, ignore them. What's my last step?
50 equals 250.
You don't have to calculate anything. Just tell me what to do and I'll use a calculator. Not sure? Paige?
Divide 0.50 to both sides.
Divide by 0.50 on both sides. Okay, so when you have a number times x, you got to use division to get rid of it.
I can't see the dot there.
And anybody know what 250 divided by 0.5 is? Yeah? Yeah, Matt?
0.05.
Or do you
25.
Not 0.05. There's going to be a 5 in there somewhere, but not 0.05. Joe?
It's 5.
5. So what does that mean? 5 what?
Toppings.
5 toppings. Yes.
That's a lot of meat in the pizza.
So if you get 5 toppings, you're going to pay the same cost for a cheese pizza or the meat pizza. Same cost.
I love my job.
I like my job.
All right. So homework tonight is going to be a reference sheet. Okay, you got about 8 minutes. So you got to take out your Chromebook and you got to go on Google Classroom.
Can you scroll down a little bit?
Yeah?
Guys, for some reason, look on the board.
I don't think that's right.
That's the code.
Sure?
That's what I had on my own thing. Maybe I'm wrong.
That's what the record of code. Does that remember? What do you have to do about my head?
So guys, if we haven't logged on yet, it's DQSWJR. Yeah, I looked on it today. I think most of you guys had signed in. All right, go on there. All right, you'll see the note from the posting from Mr. Hager and I, when you print, all right, you have, actually,
What room we print?
I'm gonna tell you right now. So you're gonna, I think when we ask you to print, I think you can select like, I think there's an option that says like show more or show all or something like that. You're gonna print the Jablonski, I wanna say it's like room 280.